Something else that you've probably noticed happens to the Earth are seasons. The seasons are actually caused by the tilt of the Earth's axis. Now, what do we mean by tilt of the Earth's axis? What this means is as we compare how the Earth rotates on its axis to how it is revolving or orbiting around the Sun, those two are shifted by 23.5 degrees. It's this shift of 23.5 degrees that then leads to all of the seasons. Now, because of this, part of the Earth is going to be tilted towards the Sun, and some of it's going to be tilted away from the Sun, depending on where the Earth is in its orbit. This is also going to mean that some of the Earth will always be tilted towards the Sun, again, depending on time of year, and some of the Earth will always be tilted away from the Earth. Now, something that's going to become important later on when you're doing the homework that I'd like to point out now. You're going to have to be able to sort how long is a day. So the way to do this is to compare the equator, where the equator is on the Earth facing towards the Sun, to where the terminator is. The terminator is this line between night and day. So as you travel through the terminator, as the Earth rotates, you're going to see a sunrise or a sunset, depending on which direction you're going. It sounds way cooler than it actually is. Anyway, so we have the terminator, this line between night and day, between light and dark. If, as the person is standing on the Earth and how the Earth is rotating, if they're in a place that, as they rotate, has a large distance between the equator up to the terminator, if this is a large distance, then that person is going to spend a lot of time in daylight, so it's going to be a very long day. If the distance from the equator to the terminator is very, very small, then as they rotate around, they're only going to spend a little bit of time in the daylight, meaning that their days are going to be very short, meaning the daylight hours are going to be very short. Okay, hopefully that'll help you understand what it is that the homework question's actually asking. Now, because of the tilt of the Earth, this means that the position of the Sun in the sky is going to change. Okay? If we're in the hemisphere that is tilted towards the Sun is going to be higher up in the sky. If we're in the hemisphere that is tilted away from the Sun, then it's going to be much lower, closer to the horizon. Well, when the Sun is higher up in the sky, this means we're going to receive more direct sunlight, and we are also going to have longer daylight hours. What this means is that that hemisphere is going to receive more energy from the Sun. If it receives more energy, then this means that the temperatures are going to be higher. So when the Sun is at its highest up in the sky, these are going to be times of summer. On the flip side, during times where the hemisphere is tipped away from the Sun, then the Sun is going to be low down in the sky. This is also going to be during the time of the year where we have the fewest daylight hours. That means that that region of the Earth is going to receive less sunlight and less energy generally, which means it's going to get colder. So this is going to be the fall and winter months. Now, one way to tell that this is what's actually causing the seasons is as you compare seasons between the northern and southern hemispheres. When it is summer in the northern hemisphere, it is winter in the southern hemisphere, and vice versa. And this is completely caused because of the tilt. So notice when the northern hemisphere is tilted towards the Sun, the southern hemisphere is tilted away. When the southern hemisphere is tilted towards the Sun, the northern hemisphere is tilted away. So the seasons are exactly flipped. I once had a friend who from South America, and at Christmas time he actually shared a traditional Christmas meal, which was sandwiches, because it's Christmas time is in the middle of summer. It is traditional for some people to actually go picnicking on Christmas because it's in the middle of summer. Whereas if you were trying to go picnicking here in the northern hemisphere, it's insane because it's the middle of winter. So remember, the seasons are exactly flipped, which is actually an evidence that the seasons are caused by the tilt of the Earth's axis. All right, here is our fourth lecture quiz question. Why do we have seasons? A, due to the tilt of the Earth, the sun's rays are more direct, making it hot, or less direct, making it cold. B, due to the elliptical orbit of the Earth, the sun is closer, making it hot, or farther, making it cold. Or C, due to the elliptical orbit of the Earth, the sun's rays are more direct, making it hot, or less direct, making it cold. Go ahead and think about it, and we'll discuss in just a bit. So why do we have seasons? The answer is A. It's all caused by the tilt, which then affects how the sun's rays are hitting the Earth. If we're tilted towards the sun's rays are more direct, making it hot. If we're tilted away from the sun, then the sun's rays are less direct, making it colder. So the correct answer is A. Now, the sun, as we've mentioned previously, appears to move around the sky. Now, that is from our point of view. So, again, if we're imagining the celestial sphere, then the Earth is the center of everything, and we pretend that the sun is moving around. Okay, so this is our false view. Again, this is not what's actually happening, but we pretend it is in certain circumstances to help us understand a little bit better. Now, what's actually going on is that the Earth is orbiting around the sun. And because the Earth is orbiting around the sun, this means that what regions of sky are up at night when the sun is not up is going to change throughout the year. So this path of the sun throughout the sky, from our point of view on the Earth, this is what we refer to as the ecliptic. And the orbit of the Earth around the sun, this defines what we call the ecliptic plane. The ecliptic plane is going to become more important later on when we start talking about other planets. We'll compare the other planets' orbits to the ecliptic plane to help us understand how they're tilted compared to our own. Okay, so because the ecliptic is tilted compared to the celestial equator, so make sure you understand all of those terms. Remember, the celestial equator is the projection of the Earth's equator out onto the celestial sphere, and the ecliptic is the path of the sun in our sky. Because the Earth is tilted compared to its orbit around the sun, this means that the ecliptic is tilted compared to the celestial equator. And it's that same 23.5 degrees that we saw before. So because of this tilt, there are actually 4 special locations. We have 2 points where the sun is the farthest away from the celestial equator, and we have the 2 points where the sun is on the celestial equator. The equinoxes are the 2 points where the sun is on the celestial equator. These are the points where the ecliptic and the celestial equator meet. On these days, because the sun is on the celestial equator, this means that we have 12 hours of daylight and 12 hours of night everywhere on the Earth. These typically occur in March and September. For the northern hemisphere, the spring equinox is around March 21st, and again in the northern hemisphere, the fall equinox is around September 21st or 22nd. Okay, the other 2 special points are where the sun is the farthest from the celestial equator. What this means from our point of view is the sun is going to be the closest to the horizon or the farthest from the horizon that it's going to get, which is also going to affect the daylight hours. When it is the lowest in the sky, then we're going to have the shortest day of the year. When it is the highest in our sky, we're going to have the longest daylight hours through the year. So for the northern hemisphere, the winter solstice is the shortest day of the year where the sun is the lowest in the sky, and this occurs around December 21st. For the northern hemisphere, the summer solstice, which is going to be the longest day of the year where the sun is the highest in the sky, this occurs somewhere around June 21st. Now you can flip those for the southern hemisphere. Now maybe you have noticed this change in length of day caused by the different seasons and the tilt of the Earth. Okay, so for example, in summer, it's not uncommon for the sun to finally set until almost 9 p.m. Whereas during the middle of winter, it's setting almost at 5:30 or 6 here in Utah. This actually has led to an interesting argument this past year with my now 4-year-old. Bedtime in our house is normally around 8 o'clock, no matter what time, because 8 o'clock is a good bedtime for our kids. Well, she noticed that the sun was still up at 8 o'clock, and so her argument, at 8 o'clock in the middle of summer. So her argument was that it couldn't possibly be bedtime because the sun is still up, and therefore she should still be up. However, this past winter, I got back at her because the sun set around 6. I said, "Oh, it's dark outside. It is bedtime, even though you haven't had dinner yet." I did not win this argument. Mom stepped in and made things all right. Now, during the summer solstice, or during the summertime, we're going to have one of the poles that is going to be tipped towards the sun. So in this case, we have the northern hemisphere summer, and notice that the North Pole is tipped towards the sun. No matter how the Earth has rotated, this region of the Earth is always tipped towards the sun. What this means is, from the perspective of people living in those regions, the sun is never going to set. On the flip side, 6 months later, notice that we have that same region where the sun is never going to rise. It is perpetual night in that case. If you've ever heard of the Arctic Circle, and I'm not talking about the restaurant, the Arctic Circle is actually defined based on the latitude that is the farthest south of the North Pole, where it will experience at least one day where the sun does not rise or the sun does not set. It's the last point where you'll have at least one day without the sun rising or setting. I love this sequence of images. So notice we've got 11:40 p.m., 12:40 a.m., 1:40, 2:40, and 3:40. So notice that the sun didn't actually set. It got close to the horizon, but didn't actually set. This is something on my bucket list, to experience at least one day where the sun does not rise or set. Now, to actually see this, you have to be very far north or very far south, but people have experienced it. Now, we've talked about the rotation of the Earth and the revolution of the Earth, or the orbit of the Earth. But the Earth actually has one more motion on top of both of those. This is what we refer to as the precession. Now, the best way to understand the precession is to actually think about a spinning top. So if you've ever played with a spinning top before, one of those things that you set spinning and it spins around really, really fast, the really, really quick motion, that is like the rotation of the Earth on its axis. But if you notice how the little peg that you hold to spin it is rotating, it makes this very slow conical motion in space. That slow motion as the axis is slowly drifting around, that is the precession. And the Earth actually precesses. This happens because of the gravitational pull of the Sun and the Moon. This causes the Earth's axis, where the north pole of the Earth is pointing, to slowly drift around in space. Now, what this means for us on the Earth, this means that the location of the North Celestial Pole actually changes in time. So right now, the North Celestial Pole is really close to Polaris, the North Star. This yellow circle traces out the path of the North Celestial Pole in time. So right now, it's very close to Polaris. 2,000 years ago, there was no North Celestial Pole, but if we go somewhere around 4,000 years ago, there was a star near the North Celestial Pole at the star Thuban, located in the constellation Draco. And so, the North Star is not always due north. It does change in time. However, one full cycle takes somewhere around 25 or 26,000 years. So what this means is, over the course of a single lifetime, you're probably not going to notice it. And that means that you can keep using the North Star to determine north pretty much until you die.